Okay, this is day 2 of our Algebra 1 unit. We didn't make a video yesterday because I knew that we were going to be reviewing a lot of yesterday's concepts today, so I wanted to save that video for today. We're going to kind of review the things that we talked about yesterday a little bit. We're going to add some concepts today that y'all have never done before, but I really don't think anything today is going to be too tricky. Okay, so we're going to talk about all of our algebra steps. We're going to talk about how to use a calculator to solve almost all of these. And then we will look at what's called identities, which are not nearly as scary as you're going to believe at first. Okay, so today the big thing that we're going to see is variables being put on both sides, which we've dealt with before. It's nothing new. I'm not going to have you write these steps down. These are the steps in algebra that we've done over and over for the last few years. They're written out a little weird, but I just want to go over them. The first step, it says to use distributive property to remove any grouping symbols, and then use properties of equality to clear decimals and fractions. Now, what they're saying there, grouping symbols are the parentheses. They group certain numbers together. Before we do anything, we want to get rid of the parentheses. Okay? You're already used because of PEMDAS to parentheses being first. Well, in algebra, they're still first. We want to get rid of them. We learned yesterday how to distribute, and that's how we're going to get rid of all of those parentheses. All right, we want those gone. Once we've gotten rid of parentheses, if it's decimals and you want to solve with the decimals, that's great. Okay? If not, multiply everything by the place value. If it's fractions, you don't want to work with fractions. Okay, so we learned yesterday how to get rid of fractions using the lowest common denominator. All right, so if you've got parentheses and fractions, you're going to want to distribute to get rid of the parentheses and then multiply everything by the lowest common denominator. And now you'll have a normal algebra problem with whole numbers. Okay, and that's kind of what we talked about yesterday, kind of leads us into this. Once we have that done, we move on to step 2 where we're going to combine like terms on both sides of the equation. If you remember, like terms are just numbers that share the same variable, the same letter. Okay, if they share the same letter, then they can be added or subtracted. If neither of them have a letter, they can be added or subtracted. Okay, and so we want to get that done on both sides because it makes it to where there's fewer numbers to work with. All right, then it says use properties of equality to get the variable terms on one side of the equations and the constants on the other. That's a fancy way of saying we want all the variables on one side, all the numbers on the other. Okay, so if we have x's on both sides of the equal sign, we only want them on one side. And we don't want numbers with it. We want to get those on the other side. We're going to do an example here in a little bit of that. Lastly, we'll solve for the variable. Usually that's with division as our final step. And then step 5 is to check your solution by going back to the original equation and plugging in your answer. If you get a balanced equation, you know you got it right. So, this right here is a very basic algebra problem. All right, in fact, there's no parentheses, nothing tricky here. But we do have variables on both sides. So, first thing we'll want to do is get all of our variables, which is 5x and 2x. We want those all on one side. And then we want our constants, or our numbers, on the other side. So, first thing I'm going to do is I'm going to deal with the variables. I either need to take away 5x or 2x. Does anybody remember which one we want to take away? The 2x. We want to take away the smaller one. Now, if you take away 5x, you'll still get the right answer. You're just going to have to deal with negatives along the way. And I know some of y'all do not like negatives. So, I would take away the 2x. So, the opposite of 2x is negative 2x or minus 2x. And I'm going to do the same thing over here. So, that's going to give me 3x plus 2 equals 14. All right, so now I have all of my variables on the same side, but I still have my constants on both sides. I've got 2 on the left and 14 on the right. So, I need to get rid of that 2. So, the opposite of plus 2 is to subtract 2. Which leaves us with 3x equals 12. Our final step here is to just divide both sides by 3 And yes, we get x is equal to 4. Okay, now we could go back up here. We could say 5 times 4 plus 2. And it should equal 2 times 4 plus 14. So 5 times 4 is 20. Plus 2 is 22. 2 times 4 is 8. Plus 14 is 22. I know I got the right answer because it balanced out. All right, if we would have got 22 equals 35, we'd have known we got something wrong. All right, so that's the blessing of algebra, is that if you have homework problems like we did last night, if you choose to go back and plug them in and check it, you'll know if you got 100, you'll know which ones you missed. So it's a good habit to get into. All right. Next thing they throw at us is using technology. Now, we talked yesterday about how to use a calculator, but I wanted to get it on film so that you guys could reference this if you needed to. Your calculator can solve almost any algebra problem that they can give you. In fact, it's very hard to find one that the calculator can't solve for you. So, it's good for us to know how to use the calculator to get this done. All right. In order to solve an algebra problem, solve for a single variable, on our calculator, the first thing you want to do is hit y equals up in the top left corner. Okay, and that's going to bring up that menu where it's y1 and y2 and all the way to y7. Well, we only need y1 and 2. And what we want to do is we want to take everything on the left, and that's going to be our y1, and everything on the right, and we're going to put that under y2. So we'll put 3.1x plus 9.2 under y1. And y2, we'd put 2.06 minus 1.15x. If there's parentheses, you're going to want to use those parentheses just like they did. If there's fractions, you can put the fractions in. I would divide the fractions up with parentheses just to make sure everything's in order. But you can type it out exactly how they give it to you. Okay? And what we're going to do then, we're going to hit the graph button. Okay, and what's going to happen when you graph, you're going to get something that's going to kind of look like this. All right, we can see our two lines. All right, I think this is y1 and this is y2. All right, but we can see the two lines. This point where they cross is actually the solution. Okay, we want to know when the x's are going to be the same on both sides. It's going to happen right here at this point. Okay, so just seeing the solution is not good enough. We want to know what x actually equals at that exact point, and we don't want to eyeball it. We want to know exactly. So the way you do that, all right, is you're going to hit second. Well, second, and then trace, because that's our calc to calculate things. So second, trace. All right, it's going to bring up our calculate menu with all the different things that we can do. We want to go down to 5 where it says intersect because we want to know where these lines intersect. Finally, you're going to hit enter 3 times. Enter, enter, enter. And it tells you that x is equal to negative 1.68. And y is equal to 3.992. Now, what is it that we're solving for? Which variable? X. I don't care about y. In fact, we're never going to care about y when we're doing this method. All we care about is x. So that right there is our solution. All right. Seems like a lot of steps. You guys have done this before. A lot of you have. A lot of you are really good at it. Okay. We had a lot of hundreds on the homework last night. I bet most of those hundreds were from people who are good with their calculator. All right, because it takes out a lot of the heavy lifting. Okay, so knowing these steps is valuable. It can take you a long way, even if you're just using it to check your answer. Okay, there's going to be times next year where your teacher's going to ask you to demonstrate each step. And you're going to have to show your work and how you do each step. just to make sure you get the right answer, you could always use your calculator to check yourself. Okay? Never be afraid to use a calculator. You're going to have them from now on. Every STAR test from here on, you're going to have your calculator. When you go to college, you're going to have a calculator. I mean, if you go work at NASA, you're going to have calculators. So use them. They're very valuable. All right. Next thing they give us is a word problem. All right, we talked yesterday about word problems. Word problems are mostly about taking a situation and rewriting that situation in algebra terms. Okay? In this particular problem, it says it takes a graphic designer 1.5 hours to make one page of a website. Using the new software, the designer could complete each page in 1.25 hours, but it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? All right. So he has his original method of making web pages, which takes a little bit longer. It's 1.5 hours. So 1.5 hours for the original. All right. We want to know how many pages. So 1.5 times the number of pages. We want to know when it's going to be the same is 1.25 hours times the number of pages plus the 8 hours it takes to learn the program. All right. So by solving this, we'll know the point at which it takes the same amount of time. So we get all our variables on the same side. All right, you get 0.25x equals 8. Divide both sides by 0.25x, or I'm sorry, by 0.25. And you would get that x is equal to 32. So at 32 web pages, that's when it takes the exact same amount of time. Okay, if he does 1.5 hours per page, or if he takes 8 hours to learn the new software, 8 pages is when it equals out. So how many pages would it take before he starts saving time? Is he saving time right now? No, 32 is when it's equal. So 33? So 33. All right, that's a tricky part that they're trying to do to you. 33 is actually our answer here because of how they worded the question, and that is a high school concept right there. In junior high, the question would be, when would they be the same? Or how many pages until it's equal? In high school, they're going to reword that, so you have to think about, all right, 32, all right, is how many web pages to where they're equal. If I want to know when the new method is faster, I'm going to have to go one more page over that. So things get a little bit more complex, and in high school, they're going to expect you to think a little bit more. Now, I can tell you this, on an EOC, which is the high school version of the STAR, they will not ask you a trick question like that. They'll keep it a lot more basic on EOC. But your homeworks and stuff next year can ask you some tricky questions like that. So be aware of it. Make sure you know exactly what they're asking. So, yeah, that can be pretty tricky. All right. Next thing they give us is grouping symbols. That's just these parentheses. Now, if you remember, a little while ago I told you the first thing you've got to do is get rid of these parentheses. We don't want to deal with them. All right, now you can use your calculator to solve this, just like you have been, and that's fine. Okay, but we also need to know how to get rid of this stuff because you're going to have to work with things later on and have to know how to do this step here. So to get rid of these parentheses, we're going to use distribution. So I'm going to distribute this 2 and the 3. So 2 times 5x is 10x. 2 times -1 is a -2. 3 times x is 3x, and 3 times 11 is 33. So now we're back to the kind of algebra problem we had earlier where we have variables on both sides. So we want to get all our variables on the same side, so I take away the lowest one. That gives me 7x minus 2 equals 33. We want all the constants or numbers on the other side, so I can add 2 to both sides. I get 7x is equal to 5, or I'm sorry, 35. Divide both sides by 7, and I get that x is equal to 5. All right. At this point, you could plug it back in. Up here, well, what's 5 times 5? 25 minus 1? 24. And then 24 times 2 would be 48. All right. And then what's 5 times 11? 5 plus 11.
16.
16. And 16 times 3 is 48. So we know we got it right. All right. So all that is, that's demonstrating what we talked about yesterday, which is distribution. Shouldn't be too tricky. All right. Here is the new concept. All right. This is something you've never done before. All right. Up until this point, anytime we had an algebra problem, they always had a solution. Okay. There are times where that's not always the case. Okay. So if we have this problem right here, what's the first thing that I should do on A? Get rid of the parentheses, and we do that by distributing. So that gives me 10x plus 12 equals 10x plus 12. What do we notice?
They're equivalent.
Yeah, both sides are equal, right? It's 10x plus 12 on both sides. Okay? Now, we could do some more stuff. We can move it around. But I'm going to tell you right now, you could stop right here. Okay, but I'm gonna go ahead and show you why it works out. Let's say you want to get all your variables on the same side, right? That's the next thing that we do. Well, which one do you want to take away? 10x or 10x? 10x. It doesn't matter what we're going to take away. It's going to be the same either way. And how do I get rid of it?
Subtract it.
Subtract it. So if I subtract 10x from both sides,
You get x.
all right, what would I be left with?
No x.
What's left on the left side?
Oh, plus 12.
A 12. And that's going to equal what? 12. Is that true? Does 12 equal 12?
Yeah.
Yeah, it does. You know when 12 equals 12? Always.
12.
It always equals the same thing, right? This is what's called an identity. Okay? It's an identity. It does not matter what number you plug in for x, you're going to get the right answer. This equation, since it balances out completely, you could plug any number in there and you're going to get the same thing on both sides because it's the same thing on both sides, right? So this is known as an identity. Okay, and your solution, if they said, what is the answer to this problem? And you work it out to 12 equals 12 or 5 equals 5, or you notice that it's the same thing on both sides, your solution is all real numbers. You could plug in any real number, and you're going to get the same thing on the left side that you get on the right.
So if you literally any number you can.
Any number, because it doesn't matter. It's going to be the same thing on the left that's on the right, because they're the same thing, right? So if you pick 5, you're going to have 10 times 5 plus 12. And on the right, you're going to have 10 times 5 plus 12. It's going to balance out no matter what number you put. So if you're solving an algebra problem and you get to a point where the left side completely matches the right side, you can stop. It's an identity. Okay, and if you were to try to graph this on your calculator to get an answer, it's going to always look like one line. Right? Because it's going to graph y1, and then y2 is going to go directly over the top of it, right? So it's going to look like one line. All right, and that's because those lines are overlapping because they're the exact same line. So we've got to learn to notice that. Now, if you were to go to y1 on your calculator real quick, all right, and you had y1 and y2, if you went down to y2 and you clicked left a few times, it'll highlight the picture of the line. You can hit enter and you can change how thick that line is. All right, so that when you graph it, it'll graph y1, which is still that skinny line. But then when it goes to graph y2, it'll be a fat line over the top of it. So you'll be able to see, okay, it's the same line. And so that's a trick that you can use. But if we just rearrange this anyway, we'll see that it's the same thing. Now, let's look at this B one. What's the first thing I should do here?
Get rid of the 3's or the negative 3's.
What do I have going on here?
Wait, I'm sorry, add those two.
Yeah, we have like terms. We have these two that need to be brought together. So, I have 9m minus 4 is equal to 9m plus 5. All right, so what do you notice right now? We have 9m on both sides. Now, do we have completely matching sides?
No.
No. So, what do you want to take away, 9m or 9m? 9m, all right, how do we do that?
You subtract it.
So I'm going to subtract 9m from both sides. I'm going to get negative 4 is equal to 5. Is that true?
No.
No. Negative 4 will never equal 5. They're different numbers. Okay? So, no matter what you plug in here, negative 4 is never going to equal 5. So what do you think your solution is here? Nothing. There is no solution. There is no solution. Because negative 4 does not equal 5. All right? And those are your big concepts from today that are new, that you did not learn in 8th grade or before, is that algebra problems can lead you to identities, where no matter what you plug in, it's true. And they can lead you to no solutions, where no matter what you plug in, it's always false. All right, if you were to graph B here, you would have two parallel lines that would never cross. All right, and so if we never have an intersect, we never have a solution. Okay? And that's the big new concept. Right? I think it's cool. But I'm a nerd. All right. That's our video then.